Okay, so 8.9 is the disk method, and we're going to talk about revolving around the x or y axis. So it says, finding the volume of a solid of revolution. Sketch the area bounded by the equations y is equal to x squared, y is equal to 0, and x is equal to 2. So that's what we're going to graph off to the side first. I suggest you get lots of colors, lots of highlighters. Okay, if you need that, right? If you're that type of person, needs it, I need it.
How much is a lot?
A lot. At least 2, bare minimum. But if you want to color code everything else. Just a reminder, I am recording. Okay, so we're first going to sketch y is equal to x squared. Okay, so we know it's going to go through here and here. And notice I'm only doing the right side of the quadratic because my next condition is y equals 0. Okay, which means I'm going to be bounded by the y-axis. I don't need to go on the negative side. Okay, then I have x equals 2. Okay, so then it says revolve it around the x-axis to create a solid. So before we do that, we're going to take our equation so that y equals x squared, and we're going to draw the mirror image of it on the other side of the x-axis. So when I do the mirror image, I'm going to do a dotted line. Okay, so the mirror image, if we were to do a reflection over the x-axis. Okay, so now I have this cone-like shape. Okay, imagine this in 3 dimensions. Okay, if I was to take my 2 blue lines and rotate them continuously around the x-axis, okay, what type of shape is going to form? So don't pay attention to like the cone shape itself, but if you were to revolve around something, you're always going to make a what?
Circle.
A circle. Okay, so we have a circle here. So that's showing that we're revolving there. And then we could draw another one to show that this is still revolving. Okay, so we just said that the area of a cross section is going to look like a circle. Because if we revolve around something, we're spinning around it, we're going to constantly create a circle. And what is the area of a circle? Pi r squared. And in this case, r, which is the radius, is going to be what? Any ideas? Say it again.
The distance from the x-axis.
Okay, the distance from the x-axis to the
Slope or graph.
the function, right? So since we're at the x-axis, which is 0, okay, we're only really looking at our equation, which is x squared. So r is equal to x squared. Okay, and we know that if we plug in the r into our area, we have pi of x squared squared. And then the other day we talked about how to find the volume, and that's when we integrate the area. So we're going to do the integral, and we're looking at x. So notice at x we went from 0 to what number? 2, right? Because it was bounded at x equals 2. We didn't go past that. So from 0 to 2 of our area, which is pi x squared squared dx. So when you're given something like this is how you would set up the graph and then also set up your integration. Okay, this gives us our formula here that we follow, and it's the volume of a solid of revolution. It says the volume is equal to the integration of a to b pi times capital R of x squared dx, where capital R of x is the distance between the axis of revolution, so in our case x, and the outside of the solid. So the outside of that function was stopped by x squared. Any questions so far? Okay, number 2 says take the region bounded by y is equal to e to the x, y is equal to 0, x is equal to 0, and x is equal to 3. Okay, then it says revolve this region around the x-axis. So this is important here. This is telling you which direction we're focusing on, which tells you which terms we're going to have the equation in, so which variable. So since we're, again, revolving around the x-axis, we know that everything is going to be in terms of x, so we don't need to rewrite our equations at all. We're first just going to graph. So I suggest you always set up a rough sketch. So this is where it's going to be helpful to know what these graphs look like. Hopefully everyone knows basics, right? Quadratic, natural log, e, etc. Hopefully, right? If not, you have this whole week next week to study that, right? You'll have nothing else to do. Okay, so I have e to the x. I have x is equal to 3. And then technically x equals to 0 is my y-axis, so I don't really need to draw that. Okay, so before I determine my revolution, I'm going to do a mirror image of e to the x. Okay, and since I really don't need to go past the negatives on the x side, I'm just going to start right at the origin and go down. And again, since I'm revolving around the x-axis, I am going to be forming, again, a circle. So remember, if I'm looking at my 2 lines here, the red lines that I have e to the x and the mirror image of e to the x, if you imagine them rotating around the x-axis and spinning, the inside or the cross section is going to be a circle. That's why we're always doing the area of a circle. Okay, so now we can set up our equation. Again, we're looking at the x-axis, and we know we started from 0 and went all the way up to 3. So this is the integral from 0 to 3, and we just follow the formula. So pi. Okay, then we talk about r. So r is where it is bounded from the x-axis to the function, and what's our function? E to the x squared dx. Okay. From here, this would be us setting it up. Okay, sometimes, just like on the quiz you guys just took, you will not always get a calculator to solve this, so you need to be able to integrate by hand. So I'm going to integrate this one with you, and then on the next one I'll just set it up, give you the answer, and you can practice the integration later. Okay, so integrating this, the first thing I would do is take out the pi because it's constant, and then I would rewrite e to the x squared as e to the 2x. So pi integral 0 to 3 e to the 2x dx. Okay, from here, in order to integrate, I have to use what? Use substitution. So let u equal to x. So du dx is equal to 2, which means dx is equal to du over 2. Okay, we plug everything back in, which means our bounds change. So we have pi integral from 0 to 6, because u is 2x, so I multiply my bounds by 2. Okay, and then I have e to the u du over 2. So instead of writing over 2, what can I do with that?
Take it out as 1/2.
Good, take it out as 1/2, so I'll just have pi halves now on the outside. Okay, so solving this, this would be pi halves of e to the u solved at 0 to 6. Which means I have pi halves e to the 6 minus e to the 0, which is pi halves e to the 6 minus 1. That's my answer. Of course, I could simplify this further if I had a calculator and I could actually give a decimal approximation. But if I'm doing this by hand, there's no way that they're going to expect you to know what e to the 6th power is by hand. Okay, so this would be a good answer to stop at. Okay, any questions on 2? You know I'm recording. You don't need to do that, right? Exactly. Okay, number 3 says take the region bounded by y is equal to 4 minus 2x, y is equal to 0, and x is equal to 0, which tells us it's bounded by the axes. Revolve this region around the y-axis. Okay, so now are we going around the x? No, we're going around y. Okay, so it says set up the integral to find the volume of a solid form. So first thing I'm going to do is draw my picture. Okay, I have y is equal to 4 minus 2x. That's just a line with a negative slope. And I know I am bounded by each of the axes. Okay, so technically I did not have to go in the negatives for the y, and I did not have to go in the negatives for the x because I'm bounded there. What that means when I keep saying I'm bounded there is I'm only really looking at this area here once I do the revolution. Okay, so if I'm going to revolve around the y-axis, that means I am going to, revolve around here. So what's going to form is it's going to form, again, a circle, just looking at a different direction. So the first thing I need to do here is, since I am given equations in terms of x, I need to rewrite them and solve them in terms of y. So I need to get x by itself. So I have y is equal to 4 minus 2x. Okay, I'd subtract 4, divide by negative 2. I get x is equal to 2 minus y halves. Okay, so now if I set up my formula here, I'm going to have the integral from, and what 2 values am I going to look at? Since I'm looking at the y-axis here. Good, just make sure you say it opposite, 0 to 4. Okay, because of this intersection of 4 right here, because of our line. So then I have pi, and then my r is going to be my function, 2 minus y halves dy, and then of course squared. Right, because we're talking about a circle, so pi r squared. Don't ever forget that square. Okay, so if you were to integrate this by hand, you need to simplify the square just like we did over here for e to the x. Okay. However, for this one, this is not as simple as just giving the square to each term. You would have to rewrite this in parentheses, and that square means we write it how many times? Twice. We write the parentheses twice, and then we do what method to simplify? FOIL method. Okay. So if you want to practice that on your own time, you should get 16/3 pi.